Okay, I'm going to visualize it before I go forward. And I think visualizing an integral is something that we don't spend enough time on. But we did do it in Math 121. But for the most part, we've been doing integrations with very little visualization of what we're looking at. So what I want to do is I want to kind of visualize what this integral is asking me to do. And it's between 0 and 1. And the integrand at 0 evaluates to 0. And at 1, it evaluates to 0 as well. What else do I know? I know whatever the integrand is between 0 and 1 is going to be positive, right? I want to just try to figure out what it looks like, though. So I'm going to write y equals, and that's the root of, this is the integrand, x, 1 minus x. And what I want to do is just, square both sides, and I get y squared. Oh, by the way, before I go forward, y has to be greater than or equal to 0, and the x has got to be between 0 and 1. I know that much, all right? So when I square both sides, what do I get? I get x, and I get 1 minus x. You get y squared. That would be x minus x squared. And I'm going to rewrite it a little bit differently. I'm going to write it as x squared minus x plus y squared is equal to 0. I'm going to complete the square. Half of minus 1 is minus a half. Square it, get a quarter. I'm going to add a quarter to both sides. And what do you get? It looks like an equation of a circle. It looks like x minus 1/2 squared plus y minus 0 squared equals 1/4, where the center of this would be 1/2 comma 0, and the radius is just 1/2. And so 1/2 0, the center's right there. And this equation of a circle, this up here is a semicircle. It's half a circle. So let's write the result down. When I'm doing any integration, it's going to be 1/2 the area of that circle. And what's that going to be? Pi r squared. And what's r for that? It's a half. I'll write that down. And what do you get there? You'd get pi, well, a quarter and a half is 1/8. So it's pi over 8. All right, so I know my answer. This is the answer. Let's take their suggestion now, complete the square. Let's go through that. And let's write the integral down. We're going to put the work down now. So looking at it, I'm going to complete the square, and we'll talk about this, and we'll take it step by step. All right? So first thing to do is just complete the square. I'm going to write this over here. This is going to be x minus x squared. I like to rewrite it a little bit differently as minus 1 x squared minus x. I'm going to complete the square in that. What I do, half of minus 1 is minus a half squared, get a quarter. And then I have to add a quarter. Let me see what I did. No, I have to minus a quarter, plus a quarter, right? Yeah, plus a quarter. I think I did okay. So what do you get over here? This is 1/4, and then minus x minus 1/2 quantity squared. All right, I'm gonna factor it, and it might seem crazy to do that, but I want to try to get that because I don't like the fractional part of it. So we're going to write down 1/4, and this would be what? It would be 1 minus 4 x minus 1/2 quantity squared. And it's getting tricky, isn't it? 1/4. And I'm just doing the radicand at this point. I'm trying to figure out what it looks like. And this would be 1 minus, well, 4 is the same thing as 2 squared. So I'm going to bring it on the inside. And that would be 2x minus 1 quantity squared. All right? Let me put on what I'm saying over here. 4 times x minus 1 squared is the same thing as saying 2 squared times x minus 1/2 squared. And I put the x on the outside. It's going to be 2 times x minus 1/2 quantity squared, which is going to be 2x minus 1. All right? And I got to take the root of that. All right? So let me emphasize what we're doing over here. We're taking the roots. All right? So we had this, we had this, we have this, we have this, and then we have this over here, which turns out to be 1/2 the root of 1 minus 2x minus 1 squared. All right, so I complete the square. Got a kind of a nice neat fashion over here. And let's just make sure we got that. And I think I got the half. I got this over here, and I see my limits of integration. All right, so I'm at that stage. Let me get my eraser out, and I'm satisfied getting there. I want to get to the next line, though. And what I did there is I don't like the 2x minus 1, so I'm going to make a substitution, make it easier for me to deal with. All right? And I'll write this one down for you. I'm going to say u is equal to, this is not a trig substitution, by the way, just making the integrand easier for me to look at, minus 1. So du would be 2 dx. That's relatively simple, isn't it? So what would you get over here? Well, if you did that, you get 1/2. The limits of integration are going to be at 0 would be minus 1. And at 1, 2 minus 1 is 1. And then you get 1 minus u squared. And dx is the same thing as a half of a du. So I'm going to take the half on the outside, and that becomes a quarter. And that's where this line is coming from here. All right? What am I going to do next? Make a substitution. Get my eraser out. I'm going to keep my important thing there, though. I need this because I may have to go back there. You know what? I don't need to go back there because I made the limits. I changed the limits. So I'm at a line of the code now that I'm going to make my trig substitution. So this said complete the square. I did that. I did make the integrand look a little simpler by making another substitution, but now I'm going to say u is equal to the sine of theta, and du is cosine theta d theta. All right? So I make my substitutions, and the first substitution I want to make is, the minus 1. So when does the sine become minus 1? At minus pi over 2. The next thing is, when does the sine equal 1? At pi over 2. Then what do I get? Well, I make my substitution. So 1 minus sine squared, relatively simple. I got that over there. And what's du? It's cosine theta d theta. All right? Now, in this interval, the 1 minus sine squared is cosine squared, and the square root of that in the interval would just be cosine theta. So you have cosine theta times cosine theta, which would be cosine squared. All right? The next thing it is, what we've been playing with this trick for a while now, is using that double angle formula. I'll write that down for you. And again, we're here, and you should feel comfortable getting to that line at this point. And let's take a look. So I want to remind you that cosine of 2 theta is 2 cosine squared theta minus 1, and the cosine of 2 theta plus 1 over 2 is cosine squared theta. This kind of reduces the degree, makes it easier for me, all right? So I pop it in, and where do I pop it in? Right over here. Let me write that down for you. So it's 1/4 minus pi over 2 to pi over 2, and we'd have cosine 2 theta plus 1. There'd be 2 on the bottom. I just bring it on the outside, all right? And I get this line over here, right? Not a bad line to be at. This integration looks relatively simple to do. I'll get my eraser out. And we're just moving through the k. All right? And what do you get over here? You get 1/8. The antiderivative cosine is sine 2 theta over 2 plus theta. Limits of integration, they go from minus pi over 2 to pi over 2. Well, let's do arithmetic now. What are you going to get? 1/8. Now, if I take 2 times pi over 2, I get pi, and the sine of pi is 0. And then you get plus pi over 2. Now, do the other part. Let's do the minus part. Get my eraser out, doohickey over there. Get my subtraction now. Minus 1/8. Plug in minus pi over 2. You get the sine of minus pi, which is 0. And then you get minus pi over 2. All right, let's write this down. You get pi over 16 plus, because minus times a minus a plus, pi over 16. And if you add that together, you get 2 pi over 16 which is pi over 8. Were we expecting to get that? We were, all right? I also want to point out to you that, a lot of times what happens to students is they say, well, software can really do a good job at these problems over here. And I want to point out, it does. It's remarkable. I fed this problem, though, to Wolfram Alpha. I was kind of curious about it, by the way. I fed it to Wolfram Alpha, and Wolfram Alpha returned something to me that looked rather crazy. I'm not saying it's wrong, by the way, but this is what it returned to me, all right? And I think to myself, that's a really bizarre-looking antiderivative. I'm not saying it's wrong, by the way. I'm just saying be aware that resorting to software is not the goal of this course, by the way. However, you should be looking at it. Thank you.